Have you ever looked up at the stars and wondered, are we alone in the universe? It's a question that has captivated humanity for millennia. Today, we're diving into the Drake equation, a fascinating tool that could help us answer that very question. This equation, a blend of astronomy, biology, and a sprinkle of cosmic wonder, attempts to calculate the odds of finding intelligent life elsewhere in the Milky Way galaxy. By the end of this video, you'll understand the equation that could answer humanity's biggest question: are we alone? Imagine our galaxy, the Milky Way, as this grand swirling canvas of stars, a cosmic light show billions of years in the making. It's alive, dynamic, with stars constantly being born, living out their lives, and eventually fading away. In fact, our galaxy is like a cosmic factory constantly churning out new stars, about 1 to 3 stars per year. These stars, these fiery balls of plasma, are the engines of life as we know it. Think of them as cosmic ovens in which the ingredients for planets, potential homes for life, are baked. Without stars, there's no light, no heat, no warmth radiating out into the vastness of space. Look up at the night sky, and what do you see? Billions upon billions of stars, each one a potential solar system, a potential island of life adrift in the cosmic ocean. So we have stars, these incredible balls of energy that light up the universe and provide the basic ingredients for life. But what about planets? Are they rare cosmic occurrences, or are they as common as grains of sand on a beach? Well, here's the good news. Almost every star seems to have planets. We've gone from a time when the only planets we knew about were in our own solar system to a time when we discover new exoplanets, planets orbiting other stars on a regular basis. Thanks to incredible advancements in technology, telescopes like Kepler have revolutionized our understanding of the universe. We can now peer into the depths of space and detect the faintest wobble of a star, a telltale sign that a planet is orbiting it. It seems our galaxy is teeming with planets, big ones, small ones, gas giants like Jupiter, ice giants like Neptune, and yes, even rocky planets like Earth. This is a profound realization. It means that our solar system, with its collection of planets, might not be so unique after all. Of course, not every planet is created equal. Just because a planet exists doesn't mean it can automatically support life. For life as we know it, at least, a planet needs to reside in what we call the Goldilocks Zone, that sweet spot around a star where it's not too hot, not too cold, but just right for liquid water to exist on its surface. Liquid water, the lifeblood of our planet, is considered essential for life to emerge and thrive. Here on Earth, water is everywhere. It's in our oceans, our lakes, our rivers. It falls from the sky as rain, it freezes into snow and ice, and it even exists within us. Water is the universal solvent, the essential ingredient that makes life on Earth possible. So, finding a planet in the habitable zone, a planet where liquid water could exist, is a major step in our search for life beyond Earth. Based on current estimates, scientists believe that roughly 1 in 5 stars has a planet located within this habitable zone. That means that for every 100 billion stars in our galaxy, about 20 billion of them could be hosting planets with the right conditions for life. Okay, so we've established that there are countless stars, most with planets, and a good portion of those planets are in the habitable zone. But here's where things get really interesting and really mysterious. Even on planets with the perfect conditions for life, how often does life actually emerge? This is where we move from the realm of astronomy and planetary science into the realm of biology, chemistry, and even philosophy. We only have one data point when it comes to life Earth. Life on Earth began remarkably soon after our planet cooled down enough to support liquid water. Does that mean life is common, easily sparked given the right conditions? Or was the emergence of life on Earth an extraordinary fluke, a 1 in a billion chance occurrence? We don't have the answer to that question yet. Until we find definitive evidence of life on another planet, the origin of life on Earth will remain one of the most tantalizing puzzles in our quest to understand our place in the cosmos. Let's say that life is common throughout the universe. Let's imagine that on some planets within those habitable zones, life has taken hold. But even if life begins, does it always evolve into complex, intelligent beings capable of looking up at the stars and asking the same questions we do? Here on Earth, life has existed for billions of years. For the vast majority of that time, life remained microscopic, single-celled organisms going about their business in the primordial oceans. It wasn't until relatively recently, at least on a cosmological timescale, that multicellular life emerged. eventually leading to the incredible diversity of plants and animals we see today. So the question becomes, how often does life on other planets make that leap from simple, single-celled organisms to beings that can build spaceships, write poetry, and ponder the mysteries of the universe? Now let's say that somewhere out there on a planet bathed in the warm glow of its star, intelligent life has evolved. They've looked up at their night sky, filled with the same sense of wonder that we feel, and asked, are we alone? But intelligence is one thing. Developing the means to communicate across interstellar distances is an entirely different challenge. Think of dolphins here on Earth. They are incredibly intelligent creatures, capable of complex communication, problem-solving, and even recognizing themselves in mirrors. But dolphins haven't developed the technology to send radio signals into space. The same could be true for intelligent life elsewhere in the universe. They might be out there, thinking, dreaming, exploring their own worlds, but they might not be using technology we can detect, or they might not have any desire to communicate with us at all. This brings us to the final and perhaps most uncertain ingredient in the Drake equation, the longevity of civilizations. Let's imagine that against all odds, an intelligent civilization does arise on another planet, and they do develop the technology to send signals into space. How long does that civilization last? Do they manage to avoid self-destruction, overcoming challenges like climate change, nuclear war, or other existential threats? Or do they, like so many civilizations throughout human history, eventually succumb to internal strife, environmental collapse, or some other unforeseen catastrophe? The history of life on Earth is a story of both incredible resilience and heartbreaking extinction. So, the question becomes, can intelligent life elsewhere learn from our mistakes? Can they achieve a level of sustainability and wisdom that allows them to thrive for thousands, millions, or even billions of years? So, are we alone? What do you think? The Drake equation doesn't give us a definitive answer, but it provides a framework, a way to think about the vast possibilities of life in the universe. It reminds us that the cosmos is full of unknowns, of mysteries waiting to be unraveled. The Drake equation keeps our minds open to the vast possibilities of the universe. It's a reminder that our search for life beyond Earth is not just about finding aliens. It's about understanding ourselves, our place in the cosmos, and the incredible diversity of life that might exist out there among the stars. Thanks for watching, and keep looking up at the stars.